This is the 8.5 Day 2 video. In this lesson, our objective is to round very small numbers and write the result as a product of a single digit and a power of 10. So it's similar to what we did in the previous video, but this time we're looking at very small numbers, or decimals in this case. So again, looking at our powers of 10, 10 is 10 to the first, 1 is 10 to the 0, 0.1, which is 1/10, is 10 to the negative first, 0.01 is 10 to the negative second, 0.001 is 10 to the negative third, 0.0001 is 10 to the negative fourth. So our exponent in this case is going to tell us how many times to move the decimal to the left. So when we have a whole number 1, for instance, if the exponent was -2, our decimal would automatically be there. -2 would tell us to move it 2 to the left, so we would get that number 0.01. Okay, and again, we want to think about negative exponents. Those are going to indicate very small numbers. Okay, and again, in this instance, we're thinking of small numbers as small decimals. So in this example, we're looking at the diameter of a plant cell. It is 0.000023 meters. We're approximating this number as the product of a single digit and a power of 10. So we're going to round to a single digit, and then everything else will turn into zeros. So we're rounding to the farthest left number, so in this case the 2. 3 would keep the 2 at 2, and then that 3 is going to be eliminated. We can factor out the 2, so that leaves us with 2 times 0.00001. And then we have that number 0.00001. So in the whole number 1, our decimal is here. So this decimal would have been moved 1, 2, 3, 4, 5 times. So that gives you that 10 to the negative fifth. So our final answer is 2 times 10 to the negative fifth. All right, again, we're going to look at 4 examples. Okay, in each of these, again, we're writing the number as a product of a single digit and a power of 10. So in number 1, we have 0.000684. We're going to be looking at rounding the 6. 8 is going to round the 6 up to a 7. So we would have 0.0007. Okay, the rest of those numbers are going to be eliminated. They technically would be zeros, and we don't need them since it's a decimal. We can rewrite this as 7 times 0.0001. Okay, and again, if we think about 1 being a whole number, the decimal would have been here. The decimal had moved 1, 2, 3, 4 times to the left, so that would be 10 to the negative fourth. So we can approximate this number as 7 times 10 to the negative fourth. In number 2, we'd be rounding to our 3 here. 2 is going to keep the 3 a 3, so we would have 0.003. We can factor out the 3, so we can write this as 3 times 0.001. And again, originally, with a 1 as a whole number, the decimal would have been right after it. So the decimal would have moved 1, 2, 3 times. So this would be 10 to the negative third. So our final answer would be 3 times 10 to the negative third. In number 3, we have 0.0000832. We're going to be rounding to the 8. 3 is going to keep the 8 and 8. So that gives us 0.00008. We can factor the 8 out. So that gives us 8 times 0.00001. And again, our original 1 would have had a decimal right after it. So this decimal would have moved 1, 2, 3, 4, 5 times. So that would be 10 to the negative fifth. And then we have our 8. In the final example, We have 0.000077. Again, we're looking to round to the farthest left value. 7 is going to round the 7 up to an 8, so we would have 0.000008. We can rewrite this as 8 times 0.000001. We want to make sure, again, our decimal would have been here, so we would have moved it 1, 2, 3, 4, 5, 6 times. So this would be 10 to the negative 6th. So our final answer would be 8 times 10 to the negative 6th. Okay, so again, these negative exponents are going to indicate that you have a very small decimal. Your large exponents are going to indicate you have a very large number, like in the first day's lesson. So keep that in mind as you are getting these answers. Make sure negative exponents give you small decimals for your final answer.